encourage you to do so. In this third example, this is the best one I'd say, we are looking at the penguin, helium-filled penguin. What makes this problem so exciting is that there are several unknowns, and in order to find the measure that we want, which is the height, we need to introduce a second unknown. This here is given to be 10, and we have some angles. 48 degrees is an angle of elevation, as is 40 degrees right there. Having a hard time picking a pen color that works real nice here. I'll write in the black area. As we go about trying to find the height, we probably will be using tangent because height is an opposite measure from that 48 degrees. But comparing within a right triangle, the adjacent is unknown. We call it x. We'll use another tangent measure for 40 degrees. Again, h is opposite of that 40-degree angle in the right triangle, the greater right triangle. And we are dividing not by x, but x plus 10. That's segment addition for you kids. Now the juicy part of this problem is when we start doing substitution. So if it's clear to you, we can solve here for height, but arbitrarily. It will be x times the tangent of 48. And if I solve this equation for height, it will be x plus 10 times the tangent of 40 degrees. Again, make sure you're in degree mode. Now, since both of these quantities are equal to h, we will set them equal to each other and make one equation that simply states x tangent of 48 equals x tangent of 40. I'm doing some distributing right now to save some space, plus 10 tangent of 40. Solving for x seems to be a challenge here, but remember back to your days of Algebra 1, when you had a variable on both sides of the equation. You simply try to isolate the variable to one side of the equation and the numbers to the other. So we will have x tangent of 48. Take away x tangent of 40. Notice how x is all on the left-hand side of my equation now, and it equals 10 tangent of 40. This is not like Algebra 1. We cannot subtract these tangent values and get something absurd like tangent of 8 degrees. That doesn't make sense. It's not a property of tangent. But we do know how to factor, I hope. So if I remove the factor of x, it will be a little bit more by itself. It's a common factor. X is being multiplied by tangent of 48. Take away x also being multiplied by tangent of 40. Now I have one more step of division. Divide by this quantity on both sides. Make sure you use parentheses. You might even have some additional parentheses when the calculator says tangent of what? Tangent of 40. Divide by all of that quantity on both sides, and you should get a value of x. X turns out to be, let me find a pen color that works better. X is approximately 30.9. And after all that, you would say, gosh, I hope we're done with this. No, I'm sorry, we're not. You just found this distance here between the base of the penguin and that first stake. And what we wanted was the height. So good news for you is there's a couple of options here. You could substitute this value for x there and determine the height by taking 30.9 times the tangent of 48. You could have also substituted x in the other equation. I just substituted. And h will be the height of the balloon, which is about 34.3 feet above the ground. There are two problems like this in your homework. I encourage you to identify them and work hard at them. Don't give up. The work takes a number of steps here, but once you're clear on your goal, finding the unknown, one value will usually lead itself to the other. For our final example, we are working on a water problem. Navigating on the water isn't as straightforward as it may seem, starting with these directions. So this diagram is given to you, but if you ever have to draw your own diagram, rather than initial position starting on the x-axis for these directions, we're always going to start on north as like our 0 degree. and then these seem to be tending to the east, so many degrees east of north. The speeds here given, 35 knots, and you're traveling at that for 2 hours, can help you to determine some specific lengths. For instance, this is 70 nautical miles in the first jaunt of the trip. And then, without mentioning a change in speed, 35 knots at 3 hours will be a little bit longer, 105 nautical miles. And hopefully it's been explained to you that that is a right angle. We have a linear pair here, 143 and 37 degrees. And 53, this is an alternate interior angle. Angle beta is also 53 degrees. Put those together, you have 90. There, now it's been explained to you. This is port, and we are trying to figure out the distance from port. That's a simple Pythagorean theorem calculation, so I'm not going to waste too much time going over how we get 126.2 nautical miles. However, what I do want to talk about is the bearing, which is that measure from north. So if you told someone, hey, we're 126.2 miles from port, they're not going to know where to find you. Are you here? Are you here? Are you here? You know, you could be anywhere within that 126 mile radius. So we're going to measure an angle here off of north to give them a direction to start heading to find us. Let's say the boat that we're on has tuckered out. So the point of this problem will be to find the angle. We can find this angle in the triangle here that they've marked as theta, and that will not be our bearing, but close to our bearing. So inverse trig functions, their job is finding angles. So I have lots of options here, but I'd like to use the measures that are kind of presumed or given to us, this 105 and this 70. You could, of course, use the 126, but what if you made a mistake? That's why I want us to use the given segments. Those are opposite and adjacent from our angles, so that means we will call upon tangent inverse of 105 over 70 to determine that angle. And again, make sure you're in degree mode. The calculator says that that angle theta is 56.3 degrees. Again, this is not your bearing. Then why do we do that, Mrs. D? Well, that angle is part of your bearing. You still need to come all the way back to north. So from north, we are this direction from north. So adding this 53 degree angle in will give us our obtuse measure for our bearing. Ooh, that's nice. That red pops. The bearing of 56.3 plus 53, or 109.3 degrees. I like to say east of north so they know for sure which direction to go. There's your bearing, distance and bearing. Finding it with a nautical problem, usually the toughest part is drawing the diagram. Do your best, work hard, work harder, not smarter. No, smarter, not harder. That's how I usually say it. Mrs. D signing out.